Just find the right place in the program, make the appropriate change, and we'll run the whole thing again.
Speech is still very complicated. Music is simpler.
Is that a question?
Yes.
The question is futile.
My interpretation of the data leaves little room for error. The art of leadership is delegation.
That information is not available. This constitutes all available data.
You know what they say. No good deed goes unpunished.
Good evening. Yowza, yowza, yowza. What is going on? It works. Of course it works. Did a bit of updating of it yesterday evening, here and there. Centre feed wasn't quite making. So I modified the design a little bit more and ended up with a good, reliable working connection. I don't know if it's this one or the one next to me. So welcome to HF antenna switcher number 37. Going to be doing a function, so writing a function to test. I need to give it loads of switching, so we need a sweep function anyway, so we'll write a nice function for sweeping backward and forth, switching from channel 1 to channel 7 and back again. It's going to be in platform IO using Arduino core, C, a derivative of C++ stroke C. Anyway, so let's just get on with it. I've been printing out a few things here. I suppose I could just show you that quickly. So on the bench we've got a pre-made SO239 and part of the shaft, and the new modified thickness of this, which just gives you just right, and it's coiled up with an 80mm piece of, actually it's like earth strap, but it's desoldering braid at the minute. So I'll just wind that up. It's quite easy to make that while it's out, so I've got that out. I've got just finished printing a couple of the cages. Go the wrong way. Let's get back off that one. So printing a couple of the cages to go. Still got the centre in that one, so just push that out. Right. Anyway, so we've got a couple of bits left over here, ready to build another one. I think the one on the desk, I think this one is the one I was testing last night. I didn't do a stream last night because I did do work on it though. I did do work on it, but it was little bits of pieces and printing out and modifying. So I don't know why I didn't stream it. It was by the time I realised I was doing a bit of work on it, too late. So anyway, let's put this there. So this, I'm not sure if this one is the one or the one on the table here. I can't remember because I should number them up really. Let me just do a quick test. Right, so we've got perfect frame. You can't see. Perfect frame ground now. That these didn't work, by the way. Hang on, let's just show you that again. The idea of putting an embossed thing just underneath this SO239 on this top and bottom lid just made it bend right, and had the opposite effect, because when you tighten it up it was bending it, so it was missing some of them. So I'd got it just right the way it was. So these are just scrap now, but lots of scrap. Anyway, let's go back to this other one. So we've got a good frame ground on it now. 0 ohms all the way round. It says 1 ohm, but it's, yeah, 1 ohm, 1 ohm, 1 ohm, 0 ohm, yeah. So yeah, it's a little bit. 1 ohm, 0 ohm. Is it good enough? I think it's good enough. It's only a frame ground that. Right, so let's do. It's all the way. And we've got a nice clicky action on it now. Lovely clicky action. Actually, really nice. Can't see it. Let's try and get it. So that's in manual mode, obviously. It's quite nice. Anyway, so I want to get you. That's all the way clockwise, which is on. This is the incomer, and this is 7. So if I just connect, keep on the incomer. Just show you the. So you've got the meter there. So if I just come onto the incomer, it says 1 ohm. Hang on. I've got to be careful I don't press the keyboard by mistake. I'll try to lever it in. So I've got 0 ohm there, so if you switch away and then switch to this one, nothing. Switch to this one, 0 ohm there. Switch to this one, nothing here, nothing there. 0 ohm on that one. And then we go from here, there, nothing. And this one, 0 ohm. Got to be careful. Let's just move that over a bit. So nothing on that one, and 0 ohm. You can't see. There it is. And I've got to get this all the way around. You can't see. There it is. 0 ohm. And the last one. Last one. There it is. Right, it's all 0 ohm. At the minute, obviously, we haven't switched it very many times. Let's put this meter away. So we've basically got optimized the design, and this bit here is the final length of it, where you need it to be. I'm just going to pull that out like that. Let's just settle for another one. Oops, I've just got to pull that out a little bit. If I can get it. Yeah, just once you've soldered it, because I've just soldered it round the. You can't see, I just soldered it round the back. And wound it up, ready, and that's what you get sticking out the top. So that's ready to go in a new one. So I could build one up. I've got two lots of shells, and I've gone ahead and modified the program. It's another thing I did off screen. I went ahead and hold on a second, I'm on the wrong window or something. Right, so I went ahead and desktop root. Yeah, so I went in the model yesterday, and what did I do? Oh yeah, I turned this back, took the emboss off it. Still got a little outline, but it's not embossed anymore. Then what else did I do? Went into the shaft and increased the width here, the height. So lowered the height, and also went ahead and made the angles better on this, because they were quite narrow, and made this thicker so I could bring this down a bit. Anyway, so this is the optimal design now that's working great, so we don't want to touch that anymore. We'll probably make a better actuator, one of them, at some point. And I went ahead and converted these clamps from half at a time to quarter again, because it prints out better, and got the height exactly right. 25.1. It's crucial sizes. Anyway, so it's all configured and pretty good. And these, I've got to replace these for nylon. Actually, the nylon ones are quite nice, actually. As in the nylon ones on there. These are quite nice. So you can put on your desk and you haven't got to worry about scratching anything. Plus, I've got a bag full of them. You can change them. They're M3 by 6mm. Put whatever you want on them. Anyway, so there's that. So what do we need to do today? We want to test what we've got so far. So now that's a finished one with the correct shaft in. Now I've printed another shaft to go on this one. So I wanted to keep everything up to date because this one actually misses. I think this one misses. I'm not sure. Let's tell you what. Put that to one side. Let's just take this off. Right, I was going to measure this one, see what the state of affairs was with this one. Let's get the meter out again. There's the other one, the one that's perfectly set up. Now this one, I'm not sure whether this one, because they're in various stages. You see these prototypes. I suppose you call them prototypes. So let's just see. Let's test the frame ground first. The frame ground should be fine all the way around. This is actually showing 0 ohms. That's 1 on that one, yeah, 0 ohm. Right. Anyway, so let's do the center feed next. Alright, so that one and there. See, I've got nothing there, look. Nothing on that one. And if I push down, hang on, what's going on? Hang on. No, I made a mistake. That's not the right. So I've got to go fully clockwise. That's the feed. I was on the wrong incomer. Yeah. So anyway, so that's fully clockwise, and then you've got. Well, I've got 1 ohm there. Oh, 0 ohm. And if I go to this one and switch it, it's 0 ohm. I think this one might have been alright actually. 0 ohm. See how it does like a bit of a jiggle? See that? That's so. It's probably. I don't know if it's okay or it's me moving it. Can't see. Yeah, so this is possibly okay, but I have modified it. The shaft. Now what I wanted to do is put the modified one in this. So I've got two exactly the same. So let's just quickly do that then. Oh, let me see if I've got some proper audio before we carry on. I've got two exactly the same. Right, okay, we seem to have audio, yeah. Okay, so anyway, I'm going to go back to this one. Oh, I need to get something on the print actually. Let me just get something printed. I've just took those things off. Right, so let's get this off, make sure it's clear. Well, I'll print that while I'm just disassembling this and changing the incomer. Right, so what I need is to finish this shaft off, I need the top piece, which I haven't got the very latest top piece. I've started throwing the old versions away because I don't want to mix them up with the new version. So let's just go over to here. So we want part of the shaft. So I've now sorted out which ones we need. Right, so I need that one. I don't need that one at the minute. So I just need to print that out while we're waiting. So let's just do that. Slice that plate up. Oh, you can't see the full thing, can you? Let's go on to that one a minute. Right, so that's sliced up. Let's print that out. It's 9p and it'll take 21 minutes. Let's just get that on the go. Then I can take this apart. This last one. I want 2 identical ones. Because I'm going to write this function in a minute that's going to switch it backward and forward all the time while we're writing, you know. So we're going to write the code to do that, and then it's my intention to, while we're streaming, just leave it running. Right, is that okay? What's going on there? Loading. Right, let that carry on for a bit. Right, so I'll go back onto this one. Can see that in the background for now. Right, so I need to now get on with undoing this. So yeah, because that one I know is spot on. Hopefully this one has got a slight difference. Let's just get somebody on the radio. Still got some noise on this thing. Can't wait to put my hustler back up instead of this. Right, let's just get on with this then. Okay, got to do some coding. So I just want to get these up to date with this one. So let's just get this shaft out of here. Do as quick as I can. And my sort of head's over the one side. Why is that? Is it because of that? Is it because I'm standing over here? Anyway, it doesn't matter. Right. Let's get this off. It's been on and off a few times, these lids have. These are nylon, little nylon M3 slotted, 6mm long. Put your own pins in. I use these. I've got a bag full, so I'm trying to. They look alright. I quite like them, but you know, I don't know. Anyway, let's take this apart. Rightio. Just there's 8 stuff. 8 screws to get apart here. So we've got Visual Studio Code set up, and we've got the Raspberry Pi Pico. I'll just quickly show you underneath there. That's the foil, and you can see the marks where it's been touching the SO239s around there. Anyway, let's just get this out. So we've got the shaft here now. I think this is one that, yeah, I'm just wondering, is it up to date? Because it did test out. Let me just have a look. There's not much in it. Well, there's not a lot in it. Let's compare it against this new one. Right, this is the latest one. Let's just compare the size of this shaft. I think, yeah, definitely. Yeah, there's definitely a change in this. Oh, and the only change it is at the minute is the thickness. Yeah, you can see it. Can you see it? And basically, it holds the it holds this contact very 0.25 of a millimeter lower. Yeah, and it gives it that bit more pressure on it. So that's why I want to change that. So now I'm going to have to unsolder. Oh no, I don't have to unsolder it because I've already got one on there. Let's just take the ball bearings out a minute. I've got to partially disassemble this somehow, because that can't come out of there. Yeah, it's probably easier just to solder it in, really. I've already soldered it to that. Yeah, let's have a think. So I could take the bottom off and put a temporary shell in. I've got to take that one out. So to do that, do I have to take... I can't get it out without undoing the bottom. So it's probably quicker just to put a soldering iron on. Let's do it with a soldering iron. Right. Let's go on to room view. What's going on with that? Printing. Oh, it's just starting to print now. Yeah. Just put something there, look. Anyway, the bit that is printing is okay. Right, let her carry on. Right, let's get old room view on the go. Got to take this over to the soldering iron. It's quicker to unsolder the end. Unsolder that bit there, the braid off it, centre feed. Than it is to... I don't think I can get it out. Probably could loosen it, but I think we won't bother. I'll just unsolder it. It's quicker. Which means I'll have to unsolder this one off here as well. So I'll just nip over the back here, back bench. Yeah, because the contact is held in a plastic that is at a set distance. Right, so if I just take that off there, this is much quicker than trying to disassemble it all into pieces. Better let the soldering iron warm up first. So anyway, let's have a look at this gadget here. There's the test jig. Can even plug in the stepper motor, and I'll probably have to turn the power supply on if I want that to work. Now sometimes you have to power it won't actually work until you've unplugged and plugged back in again. Right, that's just because I don't know, something to do with stepper motor. So yeah, that's actually spinning, you can't tell. Yeah, it's good, it's moving, but you can't see it. Actually, we can put this one on. We can put the one that's finished on. Let's do that now. So go all the way around like that. Connector has to be to the right. Arrow point to the left. So slide it on. Let's make sure it's getting on the right position. Yeah. Right, so that needs to be like that. Let's push it on and yeah, so once you put it in, manually turn it to all the way clockwise to position 7, which is that one. Then you can, hang on, just got the cable in the way. Press home and it'll home all the way to position 1. Right, the soldering iron should be warm enough now. Just to take this off here. Right, so I took that off. I might as well take this off the one I prepared earlier. It's no longer any use. Right, let me just unsolder that. Yep. And solder this back where it needs to go, just underneath here. You can't see any of this, but I'll be done in a little while. Right, that's done. We're finished there, so I'll take the soldering iron off before it burns the place down. Right. So we've got, we'll have to reuse that on the next job. This one is now defunct apart from the contact. So we'll just take this knob off. I think this knob's okay actually. Not sure if that knob is okay or not. Maybe it is, maybe it isn't. It might be. Yeah, I think it is. So we can put that on the new shaft then. This is what's no good anymore. Sorry, this bit. This bit's no. It's not pushing. It's not holding it down enough. And that shaft's different as well. So that'll be no good either. The bottom bit. So the bottom bit's okay. So I'll keep that, and we'll keep the other bit. That's too short now, so get rid of that. Now we want to retrieve our contact out of here now. Can't see, so let's go on to this other one. We need to get the contact out of here, so I need to unsolder it. The only way to get it out is to push it in a bit and get this unsolder it. I've just took my soldering iron off. Does that matter? No, I can do that later, that doesn't matter. Yeah, we don't need that for this one, so we'll leave that as a spare for next time. Leave the soldering iron off. Right, so now we've got the shell of this one. So if we, yeah, leave that like that, wind it up. Gotta make sure I wind it the right way. Now it's going the wrong way. Wind it the right way. Put the. I'm just printing out one of these now. That's what we're printing. We're just printing this. So I can just use this one, I think. Oh, hang on. There was a part. I did make it taller. This might be too small. This one. Let me have a think. No, I don't know if that's the latest one or not. So what I can do, I can retrieve one I chucked in the bin. Just see, because I made the height. Yeah, that's a good one. Right, so that can then go on here. I'll just push that over this one. That's it. Right, that's on. Put the ball bearings back. If I can chase it around the room. Right. So 2 ball bearings down the bottom, opposite each other. Then just wind this on. Pop it over top. Push it in, and yeah, that's the one. Right. So now we can put the upper cage back. It has to be on the feed. Actually, we need to wind that all the way around. Now, did I put any grease on this one? Can't remember, so let's put some grease on. It's PTFE. With, well, it's just chain oil for bicycles. So I'm just going to spray. I need to spray the bottom of the shaft. Can't remember if I did this last time, so what we'll do is I'll just put a bit extra on. Right, that's just to get to, and a bit around the top here, and then the last ball bearing. Maybe a little spray on there. Right, next. Put the yeah. Once it's all the way around, so you got to. Your feed comes in there. This is position 7. So you've got to make sure you put the stop. You point it towards the feed and pop it on. Now this shell will hold all the SO239s in place. So it's just get it in your hands and just give it a quick turn. Okay, you can just pop back on the cover. We'll just do that now. Yeah, it's printing the new shaft out. I don't know. So why did I need it? Oh, that's new shaft just for the next one. That's what that is. And I also, hang on. Yes, because that's the new shaft. Yeah, so I need to print, if I'm going to use, that's an old one. Yeah, we'll need to print new shaft apart from that bit. So anyway, so what I'm going to do as well is set up all these plates on Bamboo Studio, the whole thing in one file. I'll probably put the whole lot in actually, but I'll have to put some notes in that it's in 3 parts. So the main unit as a manual, then once you got the main unit as a manual, then you got the stepper motor add-on, all the 3D printed parts for that. Then you've got the weatherproof enclosure. Obviously, if you don't want a weatherproof enclosure, don't print it. And if you don't want a stepper motor, you just want a manual one, then don't print the stepper motor stuff. Yeah, buonasera. Right, when we get this finished, we're about to do some proper radio. Well, you know, get on the radio instead of just listening, shortwave listening. So just get around to this. I don't go too crazy with it. Possibly if you use steel ones and really clamp it down, you get even better frame ground, but I just want to see what it's like in normal use. I don't want to over tighten stuff just to get it to work. It's got to be able to work with just a normal tightening. I think that's it now. Let's just have a look. I think that's it, yeah. Right, let's put the actuator knob back on. Right, let's just see. So fully on 7. Yeah, it's going around, it's not jamming, and it's got a nice click to it, nice sounding click. Right, I suppose we ought to do the bell test again on this one. Make sure we're starting out with two the same models. Right, so just do bell test again. Right, so we've got the 0 ohms, just make sure the frame ground is good. 0 ohms, 0 ohms, 0 ohms, 0 ohms, 0 ohms, 0 ohms, 0 ohms. Right, let's do the feed next. So, feed in. Hang on, I'm overwhelmed with these plastic bits. So we've got 0 ohms there, and we'll switch to the next one. 0 ohms there. Switch to the next one. 0 ohms there. Switch to the next one. I'm not even touching that, it's just stuck in the hole. 0 ohms there. Let's get a bit of space. Zero ohms. This is 0 ohms, and the last one 0 ohms. So that's actually fantastic. Now what we want to do is write a program to add to the stepper motor. Right, so these are identical now. The one, hang on, this one here and this one, it's both using all the same components, and we didn't have a fluke, we've reproduced the same on both. Right, so I mean I've got this one here, it's the same thing I think, so just a different colour, so I could put that on there. So we'll say the black one, I'll say the black one and the white one. Okay. When you can't see it. When you push this on, you end up you dead the sound of the clicking because it's got this stepper motor on the end of it. Anyway, so there's that. So what I want to do is want to write a routine for this that goes like that and goes back again with a pause time on it, so I don't have to keep pressing it. And so I need to write a bit of a function, so let's do that then. So we've got that far. So this is still printing, it's got about 6 minutes left, that's fine. Right, let's bring up some code. Here's the code, boilerplate code. Right, okay, and we're using, what we're using now? It's just still the basic stepper motor driver we're using. Yeah, I'm still using a basic one. I did try another one and with acceleration, but I couldn't get it to switch in the right position, and I thought, well, we'll stick with this one. Right, so we've got a rotate function. It returns a void, so it doesn't return anything. There's no return parameter. So rotate, we've got direction and stepping. Now I've created some structs. I use structs in my firmware. Now you can use enum, but I prefer struct because I can work with it easier, and I can create all sorts of bit patterns from it. And because it uses in the program, it uses these wordings, you haven't got to remember any kind of value. Like the stepping is done by none, 0. When I'm homing, I step 1 at a time, and when I'm switching, I do 45 at a time, so whatever that is. So we've got antenna selected, a variable, so we've got some information for setting up the stepper driver, and we've got rotate direction, so we're enabling the stepper motor, which locks it in position. Then we're executing whatever we want to do depending on the direction. So switch the direction, so you can go clockwise. So if you look back up here, you've got direction struct, so we've got non-clockwise and anti-clockwise. We can actually switch, do the rotate function, don't actually move it. We say we don't want to go anywhere, and we can say none, and now it just allows us to do different stuff with it. So once we've finished doing what we want to do, rotate it, or minus or plus, clockwise or anti-clockwise, we disable the stepper motor. Now the reason to disable it is so you can turn it by hand manually if you want as well, once you've finished. We've got a bit of delay there. Now when that goes into the ESP32, that will be done properly, not delay. We'll have a proper timer on it, time delay built in. Right, so that oil is making me sneeze. I just got it in my fingers. It's gonna. So I wipe my fingers of this oil. Right. So then we've got the home functions, home switcher. So this is the homing routine. At the minute we've got it set to rotate. It's in a 4 next loop, counting to less than from 0 to less than 7. So 7 times it iterate the loop. And it's going to rotate anti-clockwise for the normal switching distance, which is 45 degrees, and then we've got when it's finished doing that, it goes into stepping homing, so 1 degree at a time. After it's finished getting to the first position, it homes into the stop at 1 degree, just to make sure it can actually home right against the stop. Okay, and it'll do 6 of those, and then it'll stop, and it'll automatically tell you that the antenna selected is antenna 1, because you've homed against the stop, and the first one available is antenna 1. So every time you home it, it automatically does all that. Right, we've got some setup stuff going on. Just that standard setup. As soon as it runs the setup function, it does a homes the switcher. So we do a rotate there. None. Now I don't know why we did a why did we do that? Rotate none. So direction none, and stepping none. Yeah, so we're doing nothing with it. All we're doing is enabling the stepper, disabling it, and delaying at 200 before it does anything else. Right. Anyway, so that can be probably taken out or left there, doesn't matter. Right. So the next thing is the main loop. So we're just doing some boilerplate digital reads on the input pins that are wired over to this controller. Just the buttons that are wired. When it's pressed, it'll writes to an LED, so it lights at LED. It reads at input, which happens to be input 4. Writes to LED 5. This is just boilerplate to get this working. Then it rotates. That button rotates clockwise to this switching distance, which is 45 degrees. And because it's switching clockwise, it says antenna selected is plus, whatever it was last time, +1. So if it runs this, if I press the button, it does this once. It'll rotate to the next antenna socket, so from 1 to 2 or wherever it left, and it'll increment the antenna selected, so you know which one's selected. Now if somebody's singing, right, anyway, so if it decides that your antenna is already on antenna number 7, there's no point trying to rotate it any further, so it'll do an else on it, and it'll acknowledge that you've pressed the button with the LED on, and it'll rotate clockwise to the homing. So that's from the button. So in case you've messed with it or switched it, it will rotate home into the button. And if you look at rotate, it'll just pulse it once, stepper rotate clockwise, depending on the direction. Yeah, so clockwise for homing, which is 1 degree instead of 45. Right. So then this just looks through for another button. If that's high, light a different LED up, and that middle button is the home switcher. So it just homes, runs that home routine. Now then the other one is to go anti-clockwise. So it lights up a different LED and it goes anti-clockwise to this switching. As long as your the antenna selected is greater than 1. Now, if you're not greater than 1, because you're saying anti-clockwise, there is no 0 or minus. So you shouldn't try to switch at 45 degrees at position 1. So it won't allow it. And then so it won't allow it. and it'll only minus the antenna selected if it's actually rotated it. Then if you're not less than 1, then it'll just goes to home it. And the rest of this is just to switch off the LEDs and set the rotation to non, just to cancel it out in case something's happened. So when nothing's being pressed, it just cancels it off. Right, so I need to write a little function, a nice function now that does a sweep. Okay, so we'll do that. We'll just go up the top. I'll just do it at the top of here. So now to sweep, we could probably just do it with a void. So we'll call it sweep. Right, now we don't need to pass it any parameters unless we want to change the step in. Yeah, we could just change the step in. The direction, it'll sweep one way then the other. So we don't need to know the direction. Andy, welcome. Hi Dave, how you doing? Let's say hello to Andy. Good news, Andy. Got it really working well now. So getting it, we're just going to make a little routine that switches it from antenna 1 to antenna 7 and back again and back, and repeats and repeats and repeats to see if we can't destroy it or test it continuity later on. I will get some bulbs. This weekend I'll get some bulbs and some PL259s with a reducer. I'll take the reducer out, see if I can solder the bulbs into it, and then 3D print a red shroud to go over it, similar to the old dummy loads of the early 80s that you could buy in a shop for about £5. But I'll put a 21 watt bulb on it, and automation bulb, 12 volt. I'll stick 12 volt into the incomer, and then every time it rotates it'll light up a bulb. And yeah, if I had enough colours I could colour code it like a resistor colour code. Anyway, let's just carry on writing this program. So we're going to sweep. Yeah, let's yeah, well, we could have, I'll tell you what, we'll keep the direction and the step in. We'll just pass it in. We'll just pass that in as an argument. Right. We don't need anything back off it. Or we need to be able to stop it as well. Yeah. So we need to be able to stop the sweep. Start the sweep and stop the sweep. So we better introduce something into there. We better make a new struct. Let's make a new struct. I'll just copy the structure of the struct. We'll call this one activation. Right, so we'll call that one activation. Right, and activation none. So we'll call this one start and stop. Okay, so we've got an activation now, so we can create a new, we'll just call it a byte. Activation. Right, so we've got 3 parameters we can pass into the sweep function. So we can stop it, start it, and all the rest of it. But we'd have to pass a parameter into it to get to start it. So first thing we can do is I normally do it with a switch statement. Let's do it with a switch statement rather than an if. So switch activation. I don't know how we're going to do this. I'm going to need to do this on a timer. Yeah, because once it's doing a 4 next leap, it needs to release it. So we will have to create a timing from it rather than delay. It's quite complicated. So we need an input routine, which normally I transplant this into my main web interface. It's already got the input routines and everything sorted out. But this is just a test boilerplate code, so and I've got to work a way of stopping it. So how many buttons we've got? We've got 4 buttons, one's not in use. Yeah, we're going to worry about which button we're going to use. I might have to set an extra button up for this. What I want to do is I want to get it on test, rotating back and forth, back and forth, back and forth continuously. So, in fact, I could just do that. Well, I'd have to just switch it off when you've had enough for now. So let's just do the basic function. Otherwise, I've got to start writing timing. Do time delay times without delay. You can do it, but there's no point in reinventing the wheel. We've already got that in our main code. Right, let's just do the sweep on it for now. Just basic sweep. The activation we won't use them, but so what we're going to go off. So yeah, let's switch activation. So we weren't going to do anything with it. So case activation. So none. You do the none, even though it doesn't do anything. And case activation. Start. Right, and case. Oops, too many E's. Activation. Stop. And then we'll need a default. Right, okay, so we've got our switch statements. We've got our break on that one. Right, so we've got all the conditions. So if activation is sent anything other than anything else that's not in there, that's not in this select case, switch case, it'll do default. So we don't really want to, for none and default, we want to do nothing. So it's only start and stop. So basically, to start it, now this is we're not going to be able to stop it, because once it's started, it's working with delay, so it's blocking. It's no good. We need a non-blocking timer. But for now, we'll just make it blocking, just so we can get this switching. Right. So here we go then. So for a start, we'll need to know. Well, the first thing we need to do is home it. So once it powers up, we press a button. Now we're using. So this one at the minute is the homing one. No, it isn't. Yes, it is. There. Right. So we're doing homing. So we'll have to take that function out. Let's take that function out. Just temporary, and we're just gonna replace it with sweep. Now, so activation. We're gonna say activation is start. Right, and we want direction. Let's just, doesn't really matter. Should say none, or yeah, I can start it with clockwise. just go clockwise, and then we do the step in. It's going to be one at a time, switching, not homing. Right, so that's our that's our function sorted out. So now we need to write the function. Let's go and carry on writing the function. So we've basically with the middle button on this development board, we've swapped it out. What used to home the switcher now, when we do sweep, we know when we started up the setup homes the switcher, so it should be enough. We're just reusing the button for sweeping at the minute. So we're going to go back up to sweep now. The sweep function. So we've got start. The first thing we need to do is to home it. Home the switcher. Then we need to do a for next loop. We can never break out this loop now, unless we watch for a button. So, I mean, for now it's just going to go into it. We'll have to just switch it off. It'll be an infinite loop. For now, just for testing, we'll just switch it off or reset the microcontroller till someone presses it again. Yeah. So home the switcher. Let's give it a delay. So delay, I don't know, 1 second delay. And then we want to do a for loop. So once once it's homed, we automatically know where antenna selected will be 1, because when you home it, as soon as it's homed, it's finished. It knows antenna is 1, selected as 1. So by doing that, that's fine. Right. So the next thing is direction. I suppose we could put direction, so we could switch direction. Whoops, that's not the right one. Switch direction. Case and direction. Right, clockwise. Now let's do it properly. Take case direction 1 break. Case direction clockwise. Break. We'll fill those breaks in a minute. Case direction anti-clockwise, and then we'll do a break, and then we're going to go default. You don't need all this for boilerplate testing, but if you're going to do it right, just do it right from the start. I might just copy this and paste it into the thing anyway. Right, so none and default don't do anything. Oh, right, so we need, after this case, we'll need some, if we're going to do another case in the middle of it, we'll need something like this. Right, let's just knock that over a touch. No, that's not quite right. Oh yeah, that one needs to be indented there. Right. So what's that saying? Oh, switch. Sorry, that should have been a lowercase direction. So maybe we didn't need this then. Let's try get rid of it. No, we didn't need that. Let's just bring it back. Why is that not? Oh. It's alright, I thought I was in Visual Studio there. It's important to keep everything lined up in its proper place, otherwise you just go crazy. Right, so you've got to keep it neat, get rid of ambiguity and get rid of variables, turn them into constants. Right, not literally. So if we're going to go clockwise, then we'll have to do also a step in. That's another switch case. Stepping. Right, so it's a little bit of messing around, this is, but at least you'll have the capabilities. You might want to do slow stepping down on a sweep, different kinds of sweeps, full sweep or single sweeps. Okay, stepping. Alright, why isn't it coming up with that? It's not showing me anything, why not? Stepping. Okay. None. Right, it doesn't. Oh, I've got an uppercase S, sorry. My fault. Right, case, stepping. Switching. I don't know which one was which actually. I always put them in the same order: homing and switching. Homing. I always go in the same order. Okay, stepping. We can copy and paste this switching. And then you got the default. If I could spell. Default. Right. Okay. So we've got our switch activation. We've got our switch direction and our switch stepping. So we can do the same for anti-clockwise. So what we'll do, we won't copy that over yet. I'll just save that now. So what we want now is we don't do nothing on none and default for now. So that makes it easier. So we're not going to be doing homing yet. We're just going to do switching. So yeah, so we've got the direction. Right, so we'll just do switching for now. So we'll put something in there. And we can do a simple rotate. You could just write it in. If we're not using timing, we're using blocking, we could just say use the rotate again. Right, let's just do it. So first thing we'll do, we know we've already homed. We've had a 1 second delay. Then we're going to do a switching, and we've homed, so we're on position 1 already. So I can just do a rotate. Direction. We know we're on position 1, so we've got to go clockwise. And then we're going to do a stepping. We're going to do switching, not homing. So that's that function taken care of. So that switches one way. So then we want to do a delay. How long a delay? 500 milliseconds. Yeah, or 1 second. You can do it 1 second at a time. Let's just go. I'll tell you what. Let's just go 1 second. Right, and then so we can put it in a for next loop, or we can just do it manually. Let's do it manually. So again, it'll switch again, switch again, switch again, switch again. So if we go first, it's already in 1, so it goes to 2, 3, 4, 5, 6. So 1 more to 7. And then what we'll have to do is we can either do a home. We can either home again, or we'll leave it where it is. I'll tell you what. For now, we'll leave it where it is. So I'll put a little gap there. We'll just copy this whole lot here, and we'll go anti-clockwise this time. Alright, Oh, anti-clockwise without a big C. Right, just copy that and paste it over that, and that. This is just so we can get it running quickly. So that is going to go rotate clockwise then anti-clockwise. So that will actually work. We can't stop it, but that will actually work. Now I could put the whole thing in a for next loop. I'll do that actually, so it doesn't run forever straight away. So for int I equals 0. Oops. Right, and gonna go as long as I is less than, let's just say 10 times. Less than 10, then hang on, that's another comma I want. It's one of those. We don't need spaces, so less than 10, and then I plus plus, and I put my things like this down there, and right, now we need to move the whole suspect area over a touch. Right, so where's that clockwise come? Something's happened. What have I done? Right, hang on. Oh, where's clockwise come from? Right, don't know what happened there. Right, that's it, that's indented properly. So it's going to go through 10 times, back and forward, and stop. Just to see if we got everything set right. If we haven't, we can leave it switched on and just wait until 10 times is over. So that's okay. And you could do something clever, but that'll do for now, and it'll just stop. Right, let's try that, emphasize. Let's just see what happens if we compile it. See if we've got any kind of errors. Shouldn't be any errors, it would have highlighted it, I would have thought. Now, because the select antenna selected is all done in the rotate, we don't have to worry about being in the right place. Oh, rotate was not declared in this scope, and that is because easy fix, because I put sweep above rotate and home. Right, so it needs to, if it's going to be calling those functions, it needs to see it first. So we could I can either reference it, or we can just move that routine past there. Yeah, just put that past the back, and then hopefully save and compile. See if it likes it now, or I can just declare the function at the top if I want to. Like I said, it's boilerplate code, so I'm not trying to make a finished product, I'm just trying to get it. Right, that's success this time. Right, so we'll upload it, and it won't do anything until I press the button, so let's upload it. Hopefully it'll find it. I've only a different COM port. Yeah, so I can hear it's already homing. Right, so it's homed itself. I've just seen it do it. So my home button is no longer home, but if I go, I can still press it and go all the way around, and I can go back still. So I'm homed. I can press the middle button. Let's see what happens. Smoke? Do we get smoke? Ah, problem. Ah, you know what happened? I put the home in it. I homed it. That's why it did that. How can I reset this? There's no reset button on this thing, is there? On this Pico, Tiny Pico. No, it's not Tiny Pico. Raspberry Pi Pico. It's doing the sweeping anyway. And it'll do that 10 times and then it'll just stop. So, if we had bulbs on there now and a power supply coming, you'd see each one light up. So that's the next thing. I'll have to buy some 10 bulbs or 8 bulbs, 8 PLs. Solder 8 bulbs with some leads on into there, screw them all on. I don't want it to look unsightly, so I'll have to put 3D print some red shrouds to go over it. Anyone lost count yet? Is that 10 times? So you could put your meter on and probably finish now before we get a chance. Hang on. So I put it on bleed. Stick the meter there a minute. So we know the incomers, it's all tangled up. There's nobody invented meters that don't tangle up yet. Right, oh, dropped it again. Right. So I'll put that onto the incomer. Just rest it there, and I'll put that one in there. And should it hear a bleep? Yeah. Let me gear it again now. Yeah, so I think we need some load on it. We need some bulbs, so I'll have to get on Amazon, I suppose. Amazon and order some bulbs. Or go down the local shop. I know, that seems to be carrying on and on, doesn't it? Is there something wrong with my code? Is the condition never met? No? So, I equals 0. Oh, it's just stopped. That was 10. So, if you want, we can speed it up. Right, so we go back to the code. We should have put a variable in there. Let's get a variable at the top. So we want okay, so we want a long call it sweep delay equals we'll set it for 1000. Okay, sweep delay. Is it unsigned long or long? Unsigned long. Doesn't matter. Unsigned. I can't remember if you do. Unsigned. We'll keep it along. I can't remember which one it is now. Right, so keep it like that. I'll go down here and we'll just paste in sweep delay. And what we can do is change the sweep delay and get it to switch much quicker. So I'll just set the sweep delay from up here. Right, so 250 milliseconds. Don't know if that's enough. Should be. For it to switch from one position to the next. That takes a finite, I can't remember. I don't know what I'm talking about. Finite. Infinite. Finite, I don't know. Amount of time. So anyway, I'll just upload that. We'll have a look at it. It's already got it done. It's homed it and it was in the position 1. Need to be in it. Need to put it into 7 before you start.
OCS
Right, so it's waiting for a key press. Here we go. Actually, it's got home still built in, so if I bring it all the way down to antenna 7, then press the button. Don't quite know what it did then. That's not changing, is it? Something not right. Ah. So look at the code. 250 milliseconds. Is it because I've built into the rotate a 200 millisecond delay? It is, isn't it? So yeah, we've got delay already in there. So we need to override the delay, basically. So let's change that. Let's say direction override delay. It could be a bool or a byte. Bool override delay. Right. If override delay, if not override delay 200. What have I done? Spelt it. Override day delay. If not override delay 200. Right, so let's just save all that. Right, so we're going to have a problem now on all our rotates. So we need another struct now. I'll call this one override. Yeah, we'll just get this to go faster. I want to see how fast it can go. Right, so override none. Override delay. So we've got the override. We could say active or overridden. Tell you what, let's move that to number 2. Override delay. No override. No override. Okay. So we've got those 3, that's fine. Now we're going to have to go to every occurrence of rotate. And oh, we're sending values, aren't we? Bool override. Right. Now we need to change that to a byte, sorry, byte. Override delay. So it can change this if override delay is equal to override delay no override then delay 200. Okay, it's a bit of a long-winded way of doing it. Oh yeah, if it's no override delay, if it's an override, anything else, yeah. Right, it's a weird way of doing it. Never mind. Right, so what we're going to do now is it's going to error on each of these, so we're going to have to put a override, no override. So what I'll do is it'll just carry on and do it. So we need to add that to all of these now. Everywhere there's a rotate. We'll do them in a minute. Let's go back down to here just to make our code run again still. Sweep, rotate. Yes, there's no override. Okay, there's one more there. Right, that's fine. So now we need to just say there's going to be an override here. So we want to override. Overridden. Right, overridden. So we want that in all of these. So I could have just changed the speed. Oh no, it was built in, wasn't it? That's right. It was built into the other one. Right, so we're overridden there. So now what are we overriding? Oh, the built-in delay. Yeah, that's it. Okay, so now we can speed this up. Okay, so now we get a true, instead of getting 450 milliseconds, we get 250 milliseconds. Right, okay, let's just compile it and see what we got. Right, let's upload it and switch to, I'm going to just quickly turn it over to output 7. Right, it's in its normal position. Now I've told it to home. It's homing twice, so let's just stop that minute. Right, so because it's already homed, we don't need to home it again, but we will need to home it to start switching it. But we can do a quick check. Right, so let's do a quick check. Let's say in our sweep function, so we can do if antenna selected is equal to 1. Yeah, if not, let's do if not antenna selected is equal to 1, then home the switcher. So it'll only home it if it's not on 1 already, because when it boots up it homes it to 1. We don't want to home it twice to 1. Right, okay, let's try that. Just uploading and compiling at the same time. What's this message? Right, I forgot to beat it to the home position. Anyway, let's just see what happens. Here we go. So it's 250 milliseconds. We can alter that as well. Right, let's make it faster. It's not quite fast enough. It is, but and we can just as well change it there or change it down here, really. Tell you what, let's just change it in here. Yeah. So activation start. Right, okay. Now let's just do it from the top here. Now let's keep it where it was. Right, let's go crazy. 25 milliseconds. I don't think 25 milliseconds is enough. It's going to drive it mad now. It takes a finite amount of time for it to move from one to the other, and it's certainly not 25 milliseconds. Oh, I forgot to turn it around. What I should do is stop homing it. It's already homed, isn't it? Right, here we go. Hang on. Let's make all the way around there. Alright. Oh, here we go. It's going nuts. Most people use AI for this. Oh yeah. Yeah. I used AI. There wasn't any AI when I started doing it, but I used AI on something, but now AI just, it takes away everything and it just replaces it. Stuff you never even asked to replace, it starts taking over it, and then before you know it, it's a total mess and you don't know where anything is. So you've got to be very specific. Say, I only want you to sort this one particular item. Do not touch any of the other program parts. I don't care if you've got a better way of doing it at this point in time. Right, so that's finished. It cycles already, so we could start again. It always ends up on the last one. So what I need to do is get rid of the homing out of it altogether, just for now. So out of the setup, we get rid of the homing. We don't want it to home at all because it's just going into the stop, and we don't want to home before we start. Yeah, we don't want to home the switcher. We don't care because we actually, yeah, it's okay on the first one. Tell you what, we'll get rid of that. We'll home it. It is a problem. So we could leave it in. We could home it on when he first boots up, and then we can. Let me just say AI slop. That's what. I can't even spell what. That's what they call it. AI slop. Microsoft slop. AI slop. AI is great when you want it. Don't be forced on you. They put it into Notepad now. I've had an email through Windows Insider program saying we've now improved Notepad. I'm thinking, you've destroyed it. You've put AI into that. It's no longer a Notepad. It's an editor. It's something else now. It's not. I don't care because I don't use it anyway. I use Notepad++ if I'm using it, and I'll tell you what, I've started to use Visual Studio Code for all the files, even for creating a text file or anything. So you just create a text file, you don't need anyway, it's one of them. Right, so we've got rid of that one, so we don't need the delay anymore. No point having a delay. Let's get rid of the delay. Let's get rid of the home in the switcher. It's going to home it, and what we need to do is reminder. Give ourselves a little reminder. We won't do that now. Let's just go for it. I could get to pulse 3 pulses, quick steps, a single step. So I forgot to switch it over to 7 then. Right, anyway. So, oh dear, let's get over to this. So we've got this here. It's in position 1. I could start it off. It's going to go clockwise first. There we go. Right, let's put a meter on it then. Yeah, AI is great if you've got a. If you get it to read a manual. Say, I want you to ingest this manual, and I'm going to ask you a series of questions about the manual, because I don't want to sit here reading a 300-page manual. So I'll let you read it, and I will ask you a question, and it reads it instantly. It's crazy. It is good, but you've got to be careful. Right, so we've already finished the cycle, so let's go again. I'm just holding the probes in. That's finished 20 already. So you could then just go to the next one and start the button again. Anyway, you get the idea. I mean, just testing continuity, it's not really enough. Needs some load on it. So it's gone as far as we can go for testing. Other than the mechanical test of... Can we go faster? Shall we see if we can go any faster? Go on then. I don't think we can, because it's probably beating it. Number of players 0. Yeah. Delay 0. Just put 0. No, I better put 1. Might not like a 0. That's 1 millisecond. So I don't know what it's going to do, but I'm going to switch this round to channel 7. Channel 7. Antenna output 7. So it homes without already being homed. Right, it's homed, so don't know what it's going to do. I haven't got a clue. Let's have a go. It is definitely faster, but it's certainly not 1 millisecond, because it takes longer than that to get from there to there. Right, let's stick the meter on one last time. One last time. It's already finished the 20 turns. Right, so I'll put the incomer and the meter, I'll stick it onto, I don't know, this one. Now you can go around testing them. Oh, it's finished. Hang on, go again. And again, go on. Yeah. Seems to work, so it's working. So what I need to do is get some current through it. Get some current through it. And that seemed to be okay. So yeah, sweet button. So what I need to do is give it a delay and then start it off again. That's an idea. Let's do that. We'll give it 20 operations, and then we'll delay. Once it gets to the end of this sweep delay, we'll put another delay in. Can you call? So we'll delay. We'll wait 10 seconds. Wait 10 seconds, and then can we call our own function? Probably. Right, let's find the sweep function down here. We'll just... oh. Actually, we could switch to a different idea. 9-volt battery. Yeah, that's a good idea. Yeah, put a 9-volt battery in a bulb and feed it through. So we'll activate another sweep. We're going to go do a sweep from a sweep. But so activation, we're active. We're going clockwise. Yeah, because otherwise I'd have to write the whole routine clockwise and place it in the anti-clockwise. So you could do that, but there's no point at the minute. Now we're switching, and we could change to single stepping. But there's not. The problem is, it wouldn't never get round. It never get round. We'll leave it as it is. We'll just start it again. So it gets to that point. It waits 10 seconds, then starts again. And because it's activating this, yeah, I don't know what this will do. It's an infinite loop, so let's try it. Let's just try it and see what happens. See if it can't explode it into a million pieces. Right. Oh, quick, over it, quick. I beat it. Right, if I didn't do that, it was already in the stop, and it would go back 45, back 45, back 45. Doesn't matter because it goes out on the current anyway. On this, actually, I need to feel the motor. Motor's cool, and the thin heatsink on the stepper motor driver is just cool. Right, so this will just do that, and it'll wait 10 seconds and carry on again. Should do. So anyway, I went to wait 10 seconds so I can get to have my drink. Someone asked me, they said, why do you use a measuring jug for a drink? Because I've got a pint glass and it doesn't hold as much as that. It gets empty and I get thirsty. So anyway, oh, it just started up on its own. Yeah, anyway, so what we need to do, what is the next stage after this? Yeah, more testing. So I need to put these on test. So I'll have to bulbs, need some bulbs. PLs and bulbs. I spent a lot of money this week, so I could do with not paying out any more money at the minute. Right, what can you use instead of bulbs? Need something to light up. I could use a resistor, a powerful resistor, like a 6 ohm 2 or 4 watt resistor, and then just it needs to draw current. I'd have to put it across the plus and minus through the switching, and it'd heat it up. But in order to see anything happening, I need to put an LED across it somewhere, just to shine it up so you know you're active. Anyway, I'll let that run for a bit. Is it warming up now? Just starting to get... Oh, that heatsink's getting warm now. Yeah, that driver. Yeah, that's getting warm, that is now. Yeah, I think I need to slow the stepping down. Let's slow the stepping down before we burn out our driver. Right, so we're stepping. Right, let's go back up here. I've got it on. Let's set it for, I don't know, something more realistic. 250. That's still too fast. Let's just say, 500 milliseconds. There we go. Yeah, 500 milliseconds. Right, I should interrupt that in a minute, and yeah, I'll just turn that to there. There we are. It doesn't take long to upload it. Right, let's just start that off. Gives a chance to the heatsink to cool off. Actually, it's not that. Oh yeah, it is. The motor's staying cool. The driver's got a heatsink. It gets warm. What can I say? They're supposed to get warm. I was probably overdoing it a bit. I can see a bit of a jolt on it. You can see that. I've made it a little bit too loose. So I'll have to alter the size of this carrier for the stepper motor. It doesn't matter, but I don't want to see it moving. So I'll just have to make this a little bit tighter fit. We can do that. We can do that. Let's have a look at the old model. Let's do it. Anything we notice, just get it done. Stepper motor add-on. Right, so we've got it there. So if I grab hold of these bits, it's not going to be a lot, but any improvement is better than no improvement. Just means that.
From northwest Italy, Turing like Tango Oscar, okay?
Right, so bring that in. How far do we go in? 0.25 is too much because that's nearly half a mil all the way around. So,
you are in this moment in my log.
How much plays in it? It's not a lot. Yeah, it's not a lot, so I'd say 0.25. It's not 0.5, so I think I'll do, what's that? Let's say 30, let's do 15. 0.15. Right, 0.15, you can hardly see it. Yeah, I think that's perfect. So let's just go here and bring that up to the top. There. So that's it. Let's just get rid of this line. Just made it a little bit thicker. So that means we'll have to print that out. Let's just get this last bit done and have a look at what we got printing. Okay, so we've done that. And well, we for height. I think we're fine on the height already. Yeah, we're fine on the height. Alright, let's just export that. Ready to override the other one we've done. Now it's the stepper motor add-on base. No, that's not the one. Stepper motor add-on base. There's a spacer. We'll override that. Right, so that's fine. Let's have a look at this. What's going on here? It says it's finished. We didn't need that for now anyway, so I'll go on to here and go on to the part. Where is the bit we're trying to do? This one here. Stepper motor. Save that. Right, so that one's got to come out. We've got to import the new one. Stepper motor base. Where are you? That's it. It's still showing 10th of the second. Let's have a look at the details. Yeah, that's today. Why they show you a created date, I don't know. It should be last modified date. You don't care. If you want to look at the created, you could go into the properties. I don't know, there must be a reason for it. Anyway, so that's there. Let's make sure everything's set up. 15%. We don't need much infill on this because it's just a carrier. So we don't need to make it solid. That's fine. I'm not going to print it, I'm just going to save it. Right, I don't need another one of them at the minute. So what are we missing? So we've just printed that out. We need the covers. So we need 2 covers. These. That's what we need. And they're just plain now, there's no embossed areas. Alright, let's just do that one then. And now these are solid, I think. Oh, 50%. I said, yeah, that was fine. Inner and outer brim. Alright, slice that up. Got to remember to go and get it off there. Right, so print it. I've got to go and take the other thing off and back in a second. So listen to music made The animation and the music of this was made by me. Back in a minute. Right, we're back. I've got this little thing. This thing's still going on, never shut off. It's like, what was that film? There was a film, wasn't there? The Asphyx, remember that? The Asphyx. He captured his whatever soul and he could never die. Right, so there's a little new little actuator to go on. Oh, we're missing a centre shaft. Shit, we're missing a centre shaft. I need to print the centre shaft off. Oh, that's the old one as well. Oh, there's a few things. Never mind. Right, that's the old one. Do that later. I said I'd do that later. I haven't left the soldering on, have I? No. That's fine. Right, what's next? So this thing, actually it's just lukewarm. It's alright. You can touch it, and the motor's just warm. Yeah, that's fine. Right, so hang on, let's just get this on the go. Print two of them. Might as well. So what I want to do now is put all the bits that are working in one place and put it on Make a World. If there's anyone who's got a 3D printer and want to make one, you can order these SO239s from pretty much anywhere. They're 25 by 25, so they got a certain space you've got to fit them in. They need to be panel mount with the 4 holes. It's no good getting the double one because it won't hold it in there. Right, what's next? Right, so I know last time I was trying to get. Let's start it off. Let's create a new one. So file, new project. Right. So the problem I got is I don't know we've got different stuff with different things. Yeah, so some are printed with 100% infill, and some are printed with 50, and some are printed with 50. I wonder if you can bring in a plate. I wonder if you could load a plate from. Not sure. Anyway, we'll do it manually. So we're going to save the file as. Right, it needs to start off with something like this. So now these individual parts: 7-band HF antenna switcher, G7UIV. It's traditional to put your call sign on it, isn't it? So buy G7UIV. Right, so I'll save that. I'm going to put everything on one plate because they can't. I do. All that is random. How you doing? Welcome to the live stream. Always welcome everyone who attends. Welcome. Oh, I can't spell. Oh, Kill can't spell. Welcome to the live stream. How you doing? Welcome, welcome, welcome. Yeah, can't tell what's going on here at the minute. Yeah. Yeah, there's some, this when I'm watching it back as live, it gives you wrong numbers and all sorts of stuff. But she's still going off here in the background. Let's find someone on here. Right, I've got loads of projects coming up. Right, so this one, what are we going to call this one? What do we print first? I don't know. Let's just put some stuff on it. So what do we know? We can import. Right, so we want the inner cage. Shit. 25th of the 2nd. That's today, isn't it? No, yesterday. Yeah, so that's the same one. That's the same one, so we want them. We want to orientate it, and then we need four altogether, so clone 3. So that is the chassis clamp, the outer chassis clamp. Now I'll put them on the bed according to what you should print first. I won't pile it with all different stuff because some are printed. Now these are printed at 50%. So let's call it what it is. Now it's an outer chassis clamp. Don't know. Right, let's call it chassis clamp. This is what I've called it all along. Chassis clamp. Auto orient, so it's okay as it is. The strength, we need to make it 50%. We need to tell it doesn't need a brim. It's enough surface area, it doesn't need any brim, so that's fine. Right, and it's in white ABS. So that one's finished. Now I need a new bed. Right, so we're going to import something into this one. Right, lid and base. Lid and base. There it is. No, that's not the one. We've got, that's an old one, so we want this one. Let me see when the created date of this one was. 22nd. I don't think that's the right one. Maybe it is. What did I call it? It's half the trouble is finding the right one again. I've just imported it actually. Lid and base. I haven't called it anything else, have I? Base. Just make sure it's not hiding. So 26 lid and base, that's the file I created earlier. It must be these. So I didn't do it yesterday. No, I tell you what. Let's just get them out of here. Let's get them, and then we know they're the right ones then. Right, let's just move the stepper motor add-on off. Right, so we want... No, that's not it. That's it there. Right. And these... Oh, sorry, no, these are the same. No, these are the same now. No, disregard that. Hang on. Still going at it. So, they are the same. So, I called it lid and base. No, that's there. It should be here somewhere. Oh, that's the... Yeah, we need the STL file. There it is. No, ×2. Yeah, that's it. 23rd. Oh, 25th. That's it. Date modified. That's the one. So we want that one. And it's put them... Oh, it is only one. But it's telling me to print 2, so I need to clone it. Clone it. Just want one. So let's put one down here and one just like that, close to each other like that. How do I forgot oh yeah. Oh, I see, you just move it over here. Right, so that's that. And that doesn't need... I probably did print it with a brim, so that strength... Can I... Once I'm on this one, I don't know if it'll give me the option. So we're still on 50%. I might need to go to advanced for this. We'll try changing that. Actually, is 50% enough? It is, isn't it? Yeah. That's okay for the lid, so that we'll keep it as it is, that's fine. Right, so this is going to be lid and base, or top and bottom. Lid and base, yeah, okay. Right, so that's great so far. Let's just say 52. Right, now I go back over to this one. Still got it at 52. Right, so I'm gonna have to be careful with that. Yeah, so I think you can go into advanced and split them up. Let's have a look. What's this? View all objects and settings. Yeah, I think you have to select it. Right, so here we go. Here we go. I can't see the name of the file. Print plate 1, print plate 2, that's fine. So at the minute they're both on 50%. Filament, auto. Right, it doesn't let you edit that. Oh, it does. It does let you edit it. That's fine. That's even better then. Right, so go to the next one. Let's just save the project. Right, let's add another plate. Right, I don't know what the next bit's gonna be. We'll have the inner clamps. Let's import. Right, what do I call them? Inner cages. Oh, these are separate. So you've got inner cage top and inner cage bottom. Oh, why is that? Hang on, let me find out if that's modified. Details 26, yeah, that's the right one. And that one is 26. So them two, we want them two. Alright, so we need to just move them out. I need to orientate that better. So I just need to right, let's just push that one up. Let's see if that's too close. Yeah, it's too close. So I'll come back a little bit. That's okay. Oh, let's go a bit more. Right, so we're going to put brim on this. Yeah, put a brim on this one. Yeah, stop it folding up. Now, 50%, is that enough for that? No, no. I want this 100% because it's got a little stop there that could get knocked off. Plus there's ball bearing wear. So we want 100% on that one. And it'll tell me something about the grid pattern. Needs to change to rectilinear, that's fine. Alright, support. Let's have some brim. No support. We'll have some brim on it. Brim, outer and inner. That'll do. Loop, skirt loops. I'll just keep that like that. Let's just try and slice it, see what it does for us. Yeah, that's what I'm after. Yeah, that's good. Okay. So go back here. So we've got the 3 plates. Let's call it. So these are a. What did I call them? So we've got chassis clamp. Hang on, chassis clamps. Lid and base. And we've got this one is going to be called clam. Lid and base. Top and bottom. Clam. Top and bottom clams. Okay. Right, save again, and what's next? Oh, we've got a few drop frames from 1%. Don't know when from. Going back a bit, probably. Let's just feel it. She's still going for it. Yeah, it's still within acceptable norms. Right, another plate now. What we're going to put on this one? What's left? So we've got the outer shell, the outer clamps, chassis clamps. We've got the top and bottom clams. Lid and base. Lid and base. I'm trying to think what else goes in there. Is that it? Yeah. Apart from the shaft. So we need the shaft, so we need to file import. Now the shaft are all done down here on the... Where are they gone? Where are they gone? Here they are. So you want that, that, that and that. Right, so they're up, there's 4 things. Let's just select one of them and move it. Move another one. Move it. And move it. I could say auto orientate these 2. Let's just move that. No, what happened there? Undo that. Right, so we've got to spread them about a bit. I wonder why that one ended up being twisted like that. That's weird, isn't it? Must have been the way I printed it. Strange. It's supposed to be facing that way, if anything. I'll tell you what I'll do. I'll go in here and I'll just export that one again in the right format. I suppose a lot depends on which way you're facing. So modular shaft, right, hang on. Where's it gone? There it is. So that's the top middle. Override that. Okay. And back over here. Just get rid of that one. Import. Modular shaft. Where's it gone? There it is. Oh, that's better. Oh, what? Hang on, undo that. Oh, it was okay until I moved it. So it was the right orientation until I decided to. Tell you what I'll do. I'll rotate it manually around its red. So 180 degrees. There we go. I don't know why it decided to just shift it like that. Anyway. Right, so we're going to push that. Get these a bit closer. Something like that. That needs to go up near something. So it can get some brim on it. Something like that. And this one needs to go up a bit closer. Something like this. Let's have a look. Just space evenly around, that's fine. Right, the problem is now this likes to be printed with support material. So hopefully, let's switch support, and these need to be 100%. So the strength needs to be 100%, which it is. Right, and they need to be, support needs to be switched on. I'll just leave it as it is. What did I do last time? I left it at default, didn't I? Right, so we'll leave it on there. So we've got strength 100%. we've got support, and we've got inner outer brim. Right, let's splice that up. So there's the 4 parts for the shaft. Right, so we've got the shaft, so, and it's put a bit of support in there. Has it put any support anywhere else? No, that's okay, we didn't want any support anywhere else. So that's all we want for that. Let's save that. So far we've printed everything in ABS white. Right. Where's the rest of it gone? Oh, I'm in the wrong bit. So go back into there. Let's give this a name. It's a modular shaft. Modular shaft. Okay, save it. Right, what's next? Let's make sure we got some audio. We have. Right, what's next? So we've got modular shaft. We've got the top and bottom lid, the outer, the inner, and the shaft. We need the actuator, so probably to do with 3 different actuators actually. So another plate, actuator knob, actuator knobs. Right, so this is going to be an easy one, and it's pretty much the same as file, import, actuator, plastic. No, hang on, we've got probably some more actuator plastic. Actuator. The problem is I've got to find out 16th. Tell you what, I don't know if it's the right one, so we'll go and we'll grab this one again. Export. So it's going to be called base lid chassis. I don't know what actuator. Right. Actuator knob. Actuator knob. There we go. Right, okay. Let's just make sure what we've got here. We've got the shaft, the inner shell, the outer shell, the top and bottom and the knob. Yeah, looks like everything. So we want the actuator knob. There it is. Now this one is going to be in red ABS. I haven't got the ABS in, so PLA, and it needs to. Yeah, it needs to print. Does it need to print the other way? I can't remember which way to print. Yeah, it needs to print the other way. Yeah, auto orientate it. That's it. We probably need some brim on it. Strength. This strength needs to be quite strong actually. So it got a bit of weight to it. So the strength needs to be. Where is it? Oh, I'm not on strength. Hang on. Oh, it's on 100% rectilinear. Yeah, that's good. Support. Enable support. Doesn't need support. although we'll do it anyway. And then other broom in and outer. Yeah, okay. Let's just splice it up, see what it does. Yeah, that looks good to me. Right, okay. Right, so we've got... Oh, they've turned them all red. We're going to have to work on that. Hang on. A lot depends on what colours you got. So if we go to list, we can choose the filament. So that needs to be filament 1.
Italy Uniform 1 Kilo Alpha Echo. CQ 40. India Uniform 1 Kilo Alpha Echo. Calling and listening.
Hey, what's he doing? I don't know what's going on there. CQ 40. This is India Uniform 1 Kilo Alpha Echo. Calling on 40. Right, so we've got plate 1. Needs to be white.
Uniform 1 Kilo Alpha Echo. Calling and listening.
There we go. That's the most weirdest thing of it. So, oh, it's actually 2. I don't get it. We'll have to do a bit of working on that. Right, so we'll go into this list. Plate 1 needs to be 50%. And there's 4 things on that, so all needs to be 50%. Last one. Right, then you got plate 2, which is that one. That needs to be 50% as well. Well, it doesn't need to. It can be 100%, but save some plastic. Alright, it's plate 3. That one needs to be 100%. Yeah, so that's fine as it is. Then we've got the shafts. Right, these need to be 100%. Yeah, so all 100%. Right, and then you've got 05. Yeah, that needs to be 100%. So it's only those 4. Yeah, that's fine. Right, so what else can we do here? The filament. Filament 1. I know what I need to do. I need to close that a minute. I need to go here. Oh, plus new filament. And that needs, yeah, this is it. So I need to use the white. So that needs to be white. That needs to be red. There you go. So then if I go onto the list, I can choose white for everything apart from the knob. That's quite good, really. It works, doesn't it? Inner and outer brim. I think that's it. Right, so that seems to work out okay. Very nice. So what we need to do now then is do the stepper motor add-on. The only thing we can't print is the steel ball bearings and the copper strip, contact strip. Right, so this one is going to be the stepper motor add on. Right, stepper motor add-on. So file, import, stepper motor add-on base. No. Stepper motor, where are you gone? Add-on base. Just make sure that's today's date. Yeah, that's the one. And the spacer is that one. Okay, let's just drag that over here so we can look at it and undo move. I need to move that one down a bit, something like that. Right, so you got your spacer and your bowl. Okay, let's just move that one back a bit. Keep it in the center. Go a little bit closer. Hang on, that's gone silly. Oh, hang on. That's it, and this one this way. That's it, and these only have to be they don't have to be too big. 15% they can be. Yeah. Tell you what, we'll make them 20%. Give it a bit more than it needs. Support. Does it need support? No, it doesn't need support. It needs an in and outer brim though. Right, let's splice it up, see what happens. Yeah, that's good enough. Okay, that's good enough. White's okay. Yeah, white's fine. Right, so we've got that, and for completeness, let's just save that. 2 more plates then, basically, another plate. Right, import. This is going to be the weatherproof cowl. Weatherproof enclosure, that's it. Weatherproof enclosure bottom. Here it is, weatherproof enclosure, lid and base. So we'll do the bottom first. Oh, this is quite a bit of a thing. Oh, this one will have to be in black for outside. Just make sure we've got the right one. Yeah, that's the right one. So we need to introduce here another filament. It's going to be black. Right. Right, so we go on to, hang on. Weatherproof base add-on base. Let's go on to the list. That's that one, and that needs to be black. Yeah, so we're in black. Right, okay, that's done. One more. This is the lid. Weatherproof bottom lid. There we go. And this is where the... Oh, what's that doing? Right, so I need to... Right, so I need to orientate that the right way. Oh, why has it done that as well? That was alright the way it was, wasn't it, that one? So why is it selected? Oh. Non-manifold edges, repair. Auto orientate, yeah, and select. So that needs to be black as well. Infill 20%. Yeah, I used to do them at 15 and it was fine. Okay. Because they're so thin that there's not enough room for the infill anyway. And they were fine. So what have we got here? We've got everything, I think. Yeah, got them, that, the lids, the shaft, the add-on. Yeah, there's my 37 episodes of 1.5 to 3 to 4 hours. Oh, hang on. Weatherproof add-on lid. Right, that's it then. So what I'd be able to do now is just select this file, click on whichever plate you want to print, and you can disclude some stuff if you don't want it, like making it non-printable. Like it'll only print the one you're on anyway. So if I didn't want, say that for instance, I'll just make it printable, turn it off. But at the minute that's fine, so let's save all that. Right, let's just give it to the world. Let's just give it to the world. Now it's going to be released under GPL3. Alright, I think, or somewhere thereabouts. So anyone makes any derivatives, they need to make sure they still reference G7UIV, but they can basically do with it what they want, as long as they, don't know, somehow reference the original material. Right, okay, so I'll put it on that one. I will save the file. Oh, it's already saved. Right, fair play. Right, let's close it then. So what's happening over here? Is that finished printing? I think it's finished printing, whatever it, yeah, it was only 2 leads, wasn't it? And we do need the inner shaft actually. Yeah, so let's print, oh, there's a few bits we need. We've got the top, the bottom, we need the shaft, and yeah, let's go ahead and do our first. So select this one. So what I need is, I don't need that, I've just printed it, and I'll make them not printable for now. So I want them to printing. So let's yeah, print them off. Right, it's ready. As it should have put in. Hang on. Should have put in. No, it hasn't. It hasn't put in fill. Right, why not? Infill density, no, support, yeah. So I need to add support to that shaft area, right. And that's plate, which plate is it? Hang on. Plate 4. So if I go on here, choose plate 4 and put in support. Oh, wants to know what kind of support. Support brim type. Support, where's it? Percentage. Oh no, it's just support, isn't it? Right, support, 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 and support. Okay, and has it done it? No, I have to go back a stage and then slice the plate again. Yeah, now it's put support in, that's good. Right, that's what we want. So I'll print that off. I suppose we could make that a different colour if we wanted, but we'll keep it the same. Oh, shit, hang on. I've got to go and grab those things off. Right, back in a second, I've got to go and grab them off. Right, back again. Right, just pick these off the bed just in time before it starts doing the next one. Right, so they're ready to be covered in foil. It's quite easy actually, it works alright. That self-adhesive foil. Right, it's getting late now, so I'll get this finished off. Oh, we're going to publish that next. Going to publish it. Let's go and publish it. Make a world. So if anyone's got a 3D printer, they can get printing them as well. If you want to print any and show us your progress. I don't know how you're going to get them over. I suppose I should make a face group page really. Shall we make a Facebook group? Yeah, I suppose I ought to, didn't I? Right. I'll do that later. So anyway, I'll put a link up at some point to the Facebook group, and basically you can show us your pictures on there. Right, so we'll let that carry on. I've had enough now. What time is it? What time we got? Oh, it's still early, yeah. Bloody hell, fair play. Fair play. This thing's still going. It's still going, this thing is. Yes, lukewarm, and I can pick the motor up so it's not red hot, so. Oh, let's do a quick test. Now it's done a load of switching. Let's see if we still got continuity on the inner bit and the outer bit for that matter. Let's just do a quick test. Right, so frame ground, have we still got... Oh, they're all twisted again. Of course they are. We've got all the frame grounds, let's just do the bleed test. So far so good. So far so good. Oh, it's just finished. Gotta wait for it now to 10 seconds. Ah! Come on, hurry up, I've got to... Yeah. Last one. All working still so far. Amazing, it's all working. Absolutely amazing. Right. It's better if it turns out better than what you thought it was going to do. Anyway, I'm sick of hearing it now, but right, let's get on with the rest of it. So that's just going to do that. So what we need to do now is... I know what. Go on here. Right, I need to just make those printable again. Otherwise, if someone tries to print them, they might not know how to do all this. Right, so we've got everything I've got now. Right, let's save it and publish to Make a World. Right, let's just do it, because I don't give a damn. Do you have a Bamboo Studio file? Yes, I do. Drag your browse for it. That's it there, and 2139, that's the one. Go for it. Right, it's just loading it in. Raw model files supported. Probably doesn't support SketchUp. Does it support STL? Is there STL? Yeah, STL. Right, so you want all the browse, yes, in case you want it to modify them. Can I find them all? I've got to find them all, haven't I? Right, here we go. Let's go for our actuator knobs one. Inner chassis, inner cage top. No, did I call them that? Lid and base. Hang on, chassis, yeah, inner cage top. Oh shit, hang on, I've lost that, so hold the controlling. Chassis clamps time 4 STL, yeah. Lid and base times 2, yeah. Is that right? $25th. I guess that's the one, yeah. Keep the control in. Now we want now these are all old stuff. Chassis, inner cage, bottom. Yes, definitely want that. Oh, what have I done? Right, chassis, inner cage, bottom. Stepper motor, spacer, and add-on. Chassis, no. Lid, no. Base, no. Lid and base is the same thing. Weatherproof, no. Stepper motor, add-on base. Stepper motor, oh, got it there and there. Ah, that is the one with the hyphens. Chassis part times 4. Is that the one? No, that's not it. That's chassis plastic. Oh, I'll keep swapping modes. So it's not chassis plastic. Lid, no. Weatherproof, no. No. Modular shaft. All the modular shaft. Chassis clamp, no. Stepper motor. Spacer, no. No. None of this. Lid. Chassis. Base plastic, no, none of that. So it must be something at the top. Chassis clamp. No. Oh, I've got the chassis clamps, right. So they've got the cage, inner cage, and top cage. Chassis clamps, top and bottom lid. And we've got this modular, I think that's it. Alright, so that's going to upload all them. Yeah, so okay, this looks good so far. Right. Does the model include laser and cut model? No. Is the model a cyber brick? No. So next step. Raw files. So it's an original. Right, so raw model file. Oh, we've got them here already, yeah. There's some information. Does the model include a no? Right, want some pictures now. Right, so an A4 picture. So let's see if we got some pictures. I suppose that one would do it, or a thumbnail. No, no, probably just one of those. He wants a real model. So okay, let's give it that one. Click OK. Then prioritizing app. I don't know what that is, but we'll just give it another one. Just to give it the same one, maybe, I don't know. Oh, yeah, he wants one of those, doesn't he? Alright, hang on then. Let's just do that. Right, photos of printed model. Okay, I can give you some photos. So, obviously got that one. That one, I don't know. The thumbnails. Yeah, I can do the thumbnails. Tell you what, let's just do all the thumbnails. If it'll let us have it. So, then at least they can follow the progress from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 20, 22. Where's 23? Is there no 23? Did I not do a 23? Have I missed out 23? Oh, I've got 2. Oh, there it is, sorry. My fault. I've actually got 2 of them. Oh, that was a thing and it failed, yeah. Yeah, I don't know. I'll just use that. Failed edition. I started going crazy then. Oh well. Let's do the failed one. Bugger it. Oh, let's do them all. Do them all. 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37. Is it going to say too many photos? Oh, no more than 16. Shit. Okay. I suppose we could have the last 16. 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. Model name. Right, it's the same name as the file I've just uploaded. 7 band HF. Ah, this is critical. HF receive. Is that how you spell receive? Can't remember. Yeah. Receive antenna switcher. G switcher by G7UIV. Category 3D printed test model. Other art models. 3D printer parts. No. Test models. Other art models. Can I put my home? Ham radio 3D printed that'll do. Oh, won't let you have it. Other tag oops, ham radio what other tag? I don't know. Ham radio switcher, RF switcher, 7-way. Right, and no tag is matched. Press enter to generate a custom tag. Oh god. Ham radio. Oh, it's done it. Let's close that one, that's wrong. Receive antenna switcher. Right, so it's a web interface. Web interface, I don't know, that'll do. This model includes nudity, violence, profanity. No, it doesn't. License. Allow adaptations of your work to be shared. Yes, as long as others share in the same way. Yes, as long as others share in the same way. Yes, but any derivative works must be published exclusively on MakerWorld. Right, I don't know. Allow adaptations of your work. Allow commercial use of your work. No. Allow sharing and redistribution of your work or it's delivered. Allow sharing or redistributing of your... Right, so allow adaptation of your work to be shared. Yes, as long as the others share in the same way. But any derivative works must be published exclusively on MakerWorld. Well, just leave it like that for now. I don't know. Allow adaptations to be shared. No, leave it like that. Description. It wants a description now. Damn it. Half. Oops. What's going on here? Half Greek geek. Half Greek geeks. YouTube channel. I made a switcher 7-band HF antenna. Oops. Antenna switcher, mainly for experimental. Stroke receive antenna purposes. If you use it for transmitting you must do your own tests. Okay, must do your own tests. Right, urge you to watch the live streams on YouTube. I should put a link in. Can I put a link in? At this link. Alright, let's get a link. Okay, I need a playlist really. No, that'll do for now. On YouTube, right, what is that? So it's I don't know. So is that what it is? The project. Oops, what's going on? Is designed in 3 parts. The main unit as a manual. Oh shit! As a manual. Can't spell. Manually switched. Manually switched switcher. In 3 parts. 1, 2, stepper, motor, add-on. Stepper motor add-on. To allow remote switching. Remote switching via its web interface. Via its web interface stroke cat control stroke, what's the other one? MQTT and web API. Sorry, REST API. Okay. Community post documentation. PS, a manual PDF manual is in the list of to-dos. That'll do. Alright, okay. Would you like to add non-3D printed parts or suggested filament materials for your model? Not at the minute. We'd like to add a non-3D part or suggested, yeah. Compatible, right, okay. Choose the kit and parts from Maker Supply, no thanks. Hang on, let's turn that off. Filament. I use white, black and red ABS. You will need to cover the inside of the top and bottom covers with self-adhesive I don't even know what they call it now. Aluminium foil. You need 8, 16 M3 brass inserts. What else you need? And 16 M3 by 6 millimeter machine screws. I used slotted nylon screws. And 3 by 6mm screws. What else? Anything else? Oh yeah. And you need 3 times stainless steel ball bearings, and they need to be 6 point, don't know what they are now, 6.6, 6 point, I don't know, better measure one I suppose. Better measure one. I need 3 for this next one anyway. Let's get 3 out ready. I've got to find a supply of these as well, just to get these 10 out. Alright. Alright, let's just measure a ball bearing. Not easy to do. Alright, it says 6.27. 6.3. Okay, let's just say it's 6.3. 6.3 millimeters diameter, and use some PTFE, I don't know, PTFE or spray or white lithium grease on the shaft ends and ball bearings. Anything else? Have I missed anything else? Oh yeah. You will need to use a spare relay contact of type from a what size are they? 11 pin. Are they 11 pin? 1, 2, 3, 4, 5, 6. Yeah. Type from a 11 pin 3-pole change over contact changeover relay. Again, see the live stream for size, etc. Right, is that it? Is that it? Oh, etc. And finally, you will need 8 times SO239 panel mount connectors. The type with 4 times mount fixing holes. 4 times fixing holes. Measure 25 millimeter by 25 millimeter square. Anyway, have at it. Yeah, have at it. Any derivatives? Please mention me. Mention. How do you spell that? I don't know. Can't spell to save my life. Mention me. Please mention me. G7UIV. David. Paul. Jones. AKA half Greek geek, as I have spent countless hours over up to now 37. I don't know, on average 2.5 hour episodes. Happy whatever. Happy 3D printing. Happy 3D printing. Let me know your progress on FB group. Shit, I better create a bloody group, hadn't I? Hang on. Let me just create a group. Right, groups. Create a new group. Group name. Half Greek Geek. Don't know. Yeah, half Greek Geek. G7UIV. That'll do. Choose privacy, public. Invite friends, optional. Create. Half Greek Geek G7UIV. See if it'll let me have it. Right, okay, we're on. Welcome to the home of ham radio 3D printed items. Okay, there we go. Right, so going back to, where is it, the page gone? Right, progress on the Facebook group. Hang on. Half Greek geek G7UIV. Okay, is that it? That'll do. $73s. There we go. Oh, they think that's part of that. 73s all. Right, that's it. Assembly guide and other references to do. Bill of materials to do. Add print profile. Right, is it going to let me do it? Add at least one photo of printed model is required. Print profile description. Alright. I'll leave that off there. Right, okay. Have we finished? Publish. I have read the project publish. It's going out. It's gone. Right, it's verifying, so that might take a while. So make a world. Makeaworld.com. EN half Greek geek. Verifying, yeah. Right, while I'm here, I'll have a look at some of the other stuff I've done. Alright, so how's that project going? Let's have a look at this one. How many people have had this one? 27 likes, 61 comment. One comment? See, exactly what I was looking for, thanks. Oh, no problem, have at it. What else did it say about it? What does it say? Oh, 1 boost, 70 downloads, 37 prints. There's 37 of these things around the world. Oh well. Right, let's go back to the other one. Oh, let's just go ahead. Now available to 3D print on makeaworld.com. Makeaworld.com. Search for HF antenna switcher. Right, what is it done yet? 3 models. Now this one needs to go now because it's all part of. That's the old one. Oh, that's these 2 need to go. So 2 downloads. Yeah, they need to go. So let's delete that one. That's just the same as what's in the other one, and it's all out of date anyway. This one's still in date, but let's just delete it. Right, so we're still waiting to verify the one we've just finished. Okay, we'll leave it like that. See if it lets it carry on. Still verifying. Might not like something about it. We'll let it run in the background for a bit. What's that? Models. Don't know what that is. We'll have a look later. Right, let's just leave that in the background then. 20% infill. Yeah, that's different. Right, anyway, see what's going on. Is anything printing? It's just finished by the looks of it. Okay, so I've printed, that'll be enough for one day anyway. 3 hours 15, that's plenty. Oh, this is still going. Right, this is still going. That's the wrong view. There it is. This is still going, this thing is. Right. We'll test it again another day. Let's give it one last test. One last test. And then we'll pack it up for the day. Right. So, let's go into the incomer. Let's wait till it comes round. So far so good. Yeah. Looks good. Well, there's continuity. Oh yeah, I've got to get some bulbs and PLs. I suppose I could get it on PayPal. Right, anyway, I've had enough. Thanks for watching. Let's get over to this one and have a look at what we did. Let's see if we did what we said we were going to do. Firmware function sweep test. Yeah, we did that and we did a bit more. We built the test thing. We've got loads of firmware to do yet on the web interface and the cat control and the REST API and all the rest of it. No pun intended. Anyway, I'm out of here. Welcome to, that's 37. I'm gone. Catch you on the next one. Bye bye. Hang on, let's just say bye to Andy and all 73. Yeah, have a good one, Andy. Thanks for watching, mate. Oh, I need to ask you. Now it's ready. We need to get one over to you or something. Don't know. Let me know. Let me know if you want just the parts, the whole thing, what they want. I don't know. No problem. Whatever you need, let me know. Somehow, I don't know. We'll work it out. Anyway, it's Friday night, and I'll probably be on tomorrow night as well, doing something. So, I'll catch you soon. Bye for now, mate. Have a good one. Thanks everyone for watching, and I've got to go and get a drink and a rest. Bye bye.
Just find the right place in the program, make the appropriate change, and we'll run the whole thing again.
Speech is still very complicated. Music is simpler.
Is that a question?
Yes.
The question is futile.
My interpretation of the data leaves little room for error. The art of leadership is delegation.
That information is not available. This constitutes all available data.
You know what they say. No good deed goes unpunished.